Last time we were working on finding the zeros of a function, a quadratic function like this one here. This was actually the last problem we worked on. And we were finding the zeros. And what we did was we set the function equal to 0 and tried to solve for x. And one method that we saw was we used something called the square root method, where we moved the 75 over, and then we took the square root of both sides, and we had a plus and a minus, and then we solved for x. And we did this for a few problems. We also saw a method to find the zeros of a function by factoring. Now this square root method is actually really nice. You can see that we found the solutions for this particular problem pretty quickly. And I would like to use the square root method again, but sometimes we're going to be given functions that don't look exactly like this. This one, you can see it was really easy to use the square root method because all we had to do was move this 75 over, and then we had this thing being squared. So we just took the square root. Let's look at some more problems where I want to use the square root method, but I have to do some work to get to it. So for example, this function here, I have f of x is x squared minus 6x minus 9. And I want to use that square root method. Now what happens, let's see, if I set this equal to 0 and I want to find the zeros of this function. So we get 0 is equal to x squared minus 6x minus 9. And before, when we were using the square root method, we moved the number to the other side. So we get x squared minus 6x is equal to 9. If I move this over and then just flip the equation. But notice that I have an x that's being squared. But I have this 6x, and if I move that over to this side as well, then I take the square root, then I have something on the right that involves x, and that's not good. When we want to use the square root method, we need all of the x's on one side, and we want it to be inside a square. Sort of like that last problem I was just showing you. See how we had this 3x minus 2? The x was inside the square. So to actually use this square root method, we have to use a process called completing the square. Now we've actually done completing the square before. We did this when we were learning about circles. So this should be familiar to you. So what I'm going to do for this problem is, so I set the function equal to 0. And I'm going to actually move the 9 to the other side like we did before. So we had x squared minus 6x is equal to 9. And now I'm going to put a plus blank and a plus blank. So what I want to do is I want to add something here and add it here as well, because I don't want to change the equation. So what I'm going to add is I'm going to take this part with the x, the negative 6, and divide it by 2 and square it. And I'm going to do that over here as well. Okay, so let's simplify that. This is x squared minus 6x plus, in parentheses, I have a negative 3 squared. And over here, I also have a negative 3 squared. So you see all I did, so I have this original equation here. And all I did to that one was I added something right here, and I added something on this side. So it's the same equation because I'm adding the same thing. Now, on the left-hand side, I have something really nice, which is I have x minus 3 squared. When I have this thing squared and this one squared, and then I take this one and multiply it by 2, and I get that right here, I am able to factor it. Now, another way to factor this, because this method always works, you could look at this and say, you know, I need two numbers that multiply to give me this right here is 9, and add to give me negative 6. What are they? Well, that's negative 3 and negative 3. So this part factors into x minus 3 times x minus 3, which is what I have right here. This is a really a nice trick to get something that's squared. So all you do is you take what's in the middle here, divide it by 2 and square it. And don't square it completely yet, because you want to use this number that's in the square here. That's the number that you're going to put here. Now this piece you can square, that's just 9. And so on the right-hand side, I get 18. And now you see we have transformed this function that we set equal to 0 into this one. So these are the same thing, but this side is a square is equal to a number. And now we can use that square root method. So the process from going from this one to this one is called completing the square. So if we take the square root of both sides, remember when we take a square root, we get a positive and negative. And solve for x, we get 3 plus or minus square root 18. Now we can reduce this radical. Notice that 18 under a square root is the same thing as 9 times 2. And 9 is a perfect square. So this is the square root of 9 times the square root of 2. So this is just 3 root 2. So let's put that here. X is equal to 3 plus or minus 3 root 2. So we're getting two solutions. X is 3 plus 3 root 2, and x is 3 minus 3 root 2. If you plug either one of these into this one, you're going to get 18. And also if you plug either one of these into here, you're going to get 0. So those are our two solutions. Let's try another problem. Here I have the function g of x is x squared plus 2/3 x minus 1/3. And I want to complete the square so that I can find the zeros of this function and use the square root method. So the first thing you do is you set this equal to 0. And then you move the 1/3 to the other side. And I'm going to flip, I'm going to take the mirror image here. So if I put the 1/3 here, I just flipped it so I have this piece over here and that piece over there. And then we're going to do the same thing I mentioned before, which is I put a big blank here and I put a big blank here. And I take this number in the middle, which is a positive 2/3, and I divide it by 2 and I square it. Same thing over here, square it. Okay, this part you might get into a little trouble if you're not good with fractions. So 2/3 divided by 2 is the same thing as 2/3 times 1/2. Cancel out that 1/2 and you get 1/3. So then the left-hand side is x squared plus 2/3 x plus 1/3 squared. That's equal to 1/3 plus 1/3 squared, because these are the same thing. Now on the left-hand side, what I'm going to do is I'm going to say I take one of these, which is an x. I have two of these, take one of them, plus 1/3, and then square that whole thing. So just this plus this squared, that's going to be equal to whatever's on the right-hand side, which is 1/2. And now I'm going to square this one. This is a 9th, because 1 squared is 1 and 3 squared is 9. So add these two together. Now remember, with fractions, you can't just add fractions unless they have a common denominator. So to get a common denominator, you have to multiply the bottom and the top by 3. So this is the same thing as 3/9. So 3/9 plus 1/9 is 4/9. So we get that x plus 1/3 squared is 4/9. And now we can use the square root method. Take the square root of both sides. Remember to put a plus minus on one of the sides. Now this breaks into, I don't know if you remember this, let me put it over here. The square root of 4/9, well, we can break that square root like this. And the square root of 4 is 2 and the square root of 9 is 3. So then we get x plus 1/3 is plus or minus 2/3. So to solve for x, we get negative 1/3 plus or minus 2/3. Now, this is written in the form where we get, you can see we have two solutions, and we've written both of the solutions as one equation here. But this actually breaks down really nicely. Let's separate them. We get x is equal to negative 1/3 plus 2/3, and x is equal to negative 1/3 minus 2/3. Those are our two solutions. And the reason I did that is because these you can add. So you don't have this ugly square root anymore. 2/3 plus a negative 1/3 is 1/3. So that's your first answer. And then for the other one, you get negative 3/3, which is just negative 1. So those are your two solutions. And you can plug these in if you want to double check into here, where we got this square root where we use the square root method. And you can already see if I plug in 1/3, I get 2/3, and if I square that, I get 4/9, which works. And you can also plug them into the original equation, which was way up here. So like this 1/3 and this -1, if you plug them in, where are we at? Right here. So if you plug them into this, you should get 0. And if you don't get 0, you did something wrong when you were trying to complete the square or with the square root method. Okay, I think I have 2 more problems involving this completing the square root method stuff. So here's the 3rd one. And how this one is different from the other problems is it has a 2 in front of this x squared. If you look back at the problems we did, like this one, it has a 1 in the front. And this one has a 1 in the front. Now we're looking at things that don't have a 1 in front of that x squared term. And it just adds a little wrinkle into what we were doing, but it's easy to take care of. So we set this function equal to 0, and then we divide by 2. I want to force this to be a 1 in the front. So I'm going to divide every single thing by 2. So I get 0 is equal to x squared minus 3/2 minus 1 over 2. This has an x with it. You see, just divided everything by 2, and now I have a much easier function to work with. This is something that we saw a little while ago, and we know how to work with this. So we're going to move the 1/2 to the other side. So we get a positive 1/2, and then we just put a plus blank and a plus blank. And then we take this guy here, this negative 3/2, and divide by 2 and square it, and do the same thing on this side. So let's simplify. We get x squared minus 3/2 x. Okay, remember you have to be careful with this. If you do the math, you'll see you get plus a negative 3 over 4. Squared is 1/2 plus negative 3 over 4 squared. Now we've completed the square. This side factors into x minus 3/4 squared. So we take one of these and one of these. We put it here. This is equal to 1/2 plus, and then just square this side. This is 9 over 16 because you have to square the top and the bottom, and the negative goes away when you square it. Okay, so I want to add these 2 fractions. Again, I can't just add fractions unless they have the same denominator. In order to get the same denominator, I have to multiply the top and the bottom by 8. So I have 8 plus 9 over 16. So if we simplify that, we get x minus 3/4 squared is equal to 17 over 16. Now we take the square root of both sides. Okay, so where do we go from here? Well, we move the 3/4 to the other side, and then we break this square root because this will become square root 17 over the square root of 16. So we get x is equal to 3/4 plus or minus the square root of 17 divided by the square root of 16, which is just 4. And we can combine this into a really nice fraction. Because both of these are being divided by 4, so I just put it on the bottom like that. We can't simplify this any further, so here are our 2 solutions. Let's try one more problem. Here I have k of x is 4x squared plus x plus 1. So let's set this equal to 0. Move the 1 to the other side. And then we are going to put a big blank on this side and a blank on this side. Oh, oops, did I make a mistake? What did I do differently? I forgot that I have a 4 here. And what did I say last time? When we have a number in the front, we need to get rid of that and make it a 1. So what I'm going to do is erase that. And we're going to divide every single thing by 4. So I get 0, because 0 divided by 4 is 0. 1x squared plus 1/4 x plus 1/4. See, everything is divided by 4. Now let's continue. So we move the 1/4 to the other side and we get x squared plus 1/4 x is equal to negative 1/4. Now we put our blank on both sides of the equation. Okay, and then we take this number 1/4 and divide it by 2. Square it. 1/4 divided by 2, square it. So on this side, we'll get x squared plus 1/4 x plus 1/8. You're halving a 1/4, so that becomes 1/8, is equal to negative 1/4 plus 1/8 squared. So on the left-hand side, we get x plus 1/8 squared is negative 1/4 plus, let's square this one. This is 1/64. Okay, almost done. We need to combine these fractions. So you need to figure out what you need to multiply 4 by to get 64. And I believe it's 16. You can just double check by taking 64 and dividing it by 4. You should get 16. So the top and the bottom get multiplied by 16. And we're left with x plus 1/8 squared is negative 16 plus 1/64, because I'm adding these two fractions. And I get x plus 1/8 squared is 15, negative 15/64. All right, if I had a positive number, I would continue with what I did in my other problems, which is take the square root and move the 1/8 to the other side. But I have a negative here. And let's think about this. I'm taking some number, because x is just a number, and I add it to 1/8. So I get a number, and I square that number. There's no way I can get a negative when I square a number. So here we have no solution. In fact, you could take the square root and put in your calculator square root of negative anything. Here, negative 15/64, but anything with a negative, you're going to get an error. And that should help you in case you get a little confused. There's no real solution here. All right, so as you can see, completing the square is a little complicated. It might not be the best way to find the zeros of a function. So let's recall all the different ways we found zeros. So for this function here, one thing we learned how to do is to factor. This one has no solution, so you can't actually factor it. And any other problem we looked at, like this one, where we had a square root, you could try to factor this and you'll find out that you can't, you're going to have a really hard time factoring this problem. Okay, so one way to find zeros is to factor, but that might not work, or it takes you a long time to factor. You could use the square root method, but for something like this, you have to complete the square to get to it, which will take a while. So what I'm trying to do is I'm trying to find the best method. What works the best for you, depending on the problem. And that is the question. What is the problem? What does it look like? If we had a function like, for example, let's say f of x is x squared minus 9. Well, this is really easy to factor. And it's also easy to use the square root method just by putting 0 over and moving the 9. So either one of those methods would work well for this one. Something like completing the square would just be a waste of time because you've already got it into a square. And then there's something called the quadratic formula. Now for something like this one, you can see it took a long time to get to the completing the square part. So the quadratic formula is actually a good idea for something like this. I'm going to show you what the quadratic formula is. And we'll talk more about the different problems that you'll see and which method to use. Okay, so let me scroll down. Here I have the quadratic formula. So let me just throw the quadratic formula at you. You may have seen it before. So suppose you have a function that's a quadratic. So it looks like this, where a is not equal to 0 and a, b, c are real numbers. The zeros of f are, I'm going to put this in red, x is equal to negative b plus minus square root b squared minus 4ac, all of this divided by 2 times a. So here I'm giving you a formula that no matter what kind of function you have that's a quadratic, if it was something really easy to work with, like that x squared minus 9 that we saw before, or something really crazy looking, as long as you have an a, b, a c, and this x squared term and this x, you can use a quadratic formula. So the quadratic formula will work for any quadratic. It may not be the best way to find the zeros because it takes some time to use this formula. So let's just do some examples where we use the quadratic formula. So I want to find the zeros of this function. F of x is x squared plus 4x plus 2. So the first thing I do is I set it equal to 0. Okay, we're going to use the quadratic formula, so I'm going to write the quadratic formula off to the side. I need to figure out what is A, B, and C because you can see all of those letters are being used in this formula. So A is the number in front of the x squared term. So A is 1. B is the number in front of the x term. And C is the only number without an x. So all I'm going to do is I'm going to plug these three numbers into this formula. So I get x is equal to the opposite of b, so negative 4 plus minus square root b squared, which is 16, minus 4 times a, which is 1, times c. And this square root goes over all of that stuff, divided by 2 times a. Now let's clean this up. This is x is equal to negative 4 plus minus square root 16 minus 8 divided by 2, which is negative 4 plus minus 16 minus 8 is 8, all divided by 2. And we're almost done. Let's put this solution up here. Okay, let's see if we can simplify the square root of 8. Well, the square root of 8 is the square root of 4 times 2, because 4 times 2 is 8. And this is a perfect square. So then this is 2 root 2. So x is equal to negative 4 plus or minus 2 root 2 divided by 2. And notice that each piece has a 2 in common. We can factor out a greatest common factor. Now, a lot of students make a mistake here. They'll get up to here and then they just get the wrong answer by doing this one thing where they say, oh, this is divisible by 2, this is divisible by 2, cross that out and make this a negative 2. That is incorrect because this 2 on the bottom is going into the negative 4, but at the same time it's going into this 2 as well. It's 2 root 2. So don't fall in that trap. What you want to do instead is this 2 needs to go into each piece here. So you get x is equal to negative 2 plus or minus root 2. And that is your solution. So it went into this 4 and it went into this 2 here. Let's try another example. Here I have g of x is x squared plus 6x plus 1. Okay, we need to figure out a, b, and c. We set this equal to 0. Okay, a is the number in front of the x squared, which is 1. B is the number in front of the x, which is 6. And c is the number right here, which is the only thing without the x, which is a 1. The quadratic formula is the opposite of b plus minus square root b squared minus 4ac, all divided by 2a. Now just plug all of those pieces in. So we get -6 plus minus square root. 6 squared is 36, minus 4 times 1 times 1, all divided by 2 times 1. Okay, let's simplify. X is equal to -6 plus or minus. So this is just 4, because 1 times 1 times 4 is 4. 36 minus 4 is 32. And then on the bottom we just have 2. Let's see if we can break this 32 up. So 32 is 16 times 2. So the square root of 32 is the square root of 16 times the square root of 2. The square root of 16 is 4. So we can, instead of writing square root 32, we can say that this is equal to 4 root 2 over 2. And now notice that we have a 2 in common on the top and the bottom. So our final answer is x is equal to -3 plus or minus 2 root 2. I just divided everything by 2 to get rid of that. And here are my 2 answers. What else do we have? Okay. Let's write out the A, B, and the C. A is 2, the number in the front of the x squared. B is 5, C is 3. Quadratic formula is opposite of b plus minus square root b squared minus 4ac divided by 2a. Okay, opposite of b is -5 plus minus square root b squared is 25 minus 4 times 2 times 3, all divided by 2 times 2. So I get x is equal to -5 plus minus square root 25. Okay, let's be careful here. So we have 6, and then we have a 4, so I think that's 24 divided by 4. So we get -5 plus or minus, this is the square root of 1 over 4. So x is equal to -5 plus or minus 1, because the square root of 1 is just 1 over 4. Now, there's no reason to leave this like this. So there's no square roots, so we can actually simplify this. We have 2 answers. X is -5 plus 1 over 4, and x is -5 minus 1 over 4. -5 plus 1 over 4 is -4 over 4. And the one on the bottom is -6 over 4. So -4 over 4 is just -1. That's our first solution. And then this one is x is equal to, we can divide the top and the bottom by 2. So those are our 2 answers. Okay, I have one more, I think, that I want to show you. Let me just make sure that's the last one. Yeah, that's the last one. This one's interesting because something bad is going to happen. I guess you could think it's bad if you don't know what to do. So if we're going to set it equal to 0, we're trying to find the zeros of this function. So you write down A, B, and C. A is 4, B is 1, C is 1. Now notice that I never gave you any negatives here. You know what? I think I want to give you a negative. I'm going to make this a -1, just so that we have some experience with a negative. So sorry about that, but I want to have a little experience. So I changed B to -1. Okay. So x is going to be the opposite of b, plus minus square root b squared minus 4ac, all divided by 2a. I keep saying opposite of b because this is a -1. So you want to take the negative of that, which is going to be 1. So we're not going to put -1, we're taking the opposite. Plus minus square root, well, -1 squared is 1, minus 4 times 1, all over 2 times 4. Okay, so the negative took into effect here. It changed this piece. And then when we did the negative, when we squared it, we still got 1. So that part doesn't matter. Sometimes if you have A and C are negative, you're going to put negatives here. But if you do regular multiplication, so you just have to be careful. So if this was a negative and a negative, you just multiply all the numbers together, and then you'd have 3 negatives, which would make a negative. So just be careful when you play with negatives. And if you have a negative down here, this would be -8. But anyway, let's just continue. So we get x is equal to 1 plus or minus square root 1 minus 16 over 8, which is 1 plus or minus square root -15 over 8. So do you see what has happened? We have a negative under a square root. Okay, we cannot have negatives under the square root, so we have no solution. Whenever you have a negative, so let me write this down, no negatives under square roots. Whenever that happens, you always get no solution. Another thing that could happen is you get the square root of 0. So if this simplified to just 0, then the square root of 0 is 0, and you're going to get 1 solution. Because if this goes away, you'll get 1 plus 0, 1 minus 0, which is just going to be 1. So you get 1 over 8. So you would have 1 solution. Now, if you get anything other than a negative or 0 here, you always have 2 solutions. So the next question, before we move on to points of intersection, something you might want to know is what process or what method should I use to solve my solve for zeros for my quadratic function? And the answer is it depends. So let me write that here. What's the best method for finding the zeros of a quadratic function? And the answer is it depends on the function. So let me tell you the different ways and the pros, I guess, and the cons of each way. So we had factoring. We had square root method. And we had completing the square. And then we had quadratic formula. Those are the 4 methods we've looked at. Factoring the square root method are the quickest. I think square root method is the quickest, and then factoring. But the problem is sometimes they don't work if your function is not easily factored or where you can't use the square root method. So if you had something like, let's say, f of x is 4x plus 4. Let's say 4x squared plus 4x. So something like that. This is really easy to factor. The greatest common factor is a 4x and x plus 1. Then you can see right there what the solutions are. You say, bam, x is 0, x is -1. We're done. And the square root method works well if we have something like we've seen before, like x minus 3 squared minus 12. We could just set it equal to 0, move the 12 over, take the square root, bam, we're done. A lot of the functions we've seen don't look like this. They're not that easy to factor. If we have a trinomial, sometimes that's easy to factor. So if we had something like g of x is equal to x squared minus, let's say, x plus, Actually, let me make this a minus 20. So here's something that you could actually factor. This factors into an x minus 5x plus 4. But then there's some things that are not easy to factor. You might get something where you need to have a square root involved. And when that happens, and you're just running into problems you can't factor, you don't want to go with this method. So you can only use these methods when the problem is really nice and easy to solve. And you have to like just do this enough times with practice, you'll figure out which ones are really easy to factor and use the square root method. Completing the square, I would hardly ever recommend using this. This is really just too complicated. I wouldn't use it, but the reason we learn it is because the quadratic formula actually comes from completing the square. The quadratic formula is easy to use, not really quick, because you have to put everything in your formula, simplify it, but it always works. So you can use this for any type of function you're given, if it's a quadratic. Like factoring, like I said, if we have something that's you can't factor, you can't use factoring to find the zeros. The square root method, if it's not written in this nice way, sometimes it's going to take a lot to get to something that looks like this by rearranging that formula. But the quadratic formula, you have this formula, you just have to figure out what A, B, and C are, and then you can just plug everything in. And it's easy to use. So it depends on the problem. You have to look at what you have, ask yourself, can I factor it easily? Or can I just set it equal to 0 and take a square root? If I can't do that, maybe I should use the quadratic formula. Okay, let's move on. Let's talk about points of intersection. How many points of intersection are possible when a line intersects a parabola? So let's draw XY plane. Let's say we have a parabola. You can put the parabola wherever you want. Let's say this is the lowest point on the parabola. And let's give ourselves a line, something like this. I want to know what's the total number of points where the two intersect, the total possible number of points. So like for this example, you can see that we intersected 2 times. So we can intersect 2 times. And if we move this line, let's say we move it up here, so something like this, you can see that we would intersect it 2 times as well. And as long as this parabola keeps going up, if you move the line further up, you would always hit this graph 2 times. But another thing we could do is we could move the not the parabola, but the line, we could move it down. You could move the parabola up if you want, but it's easier to just move the line down. So if we have this line instead, you can see that the line and the parabola don't intersect at all. So 0 times is a possibility. Depending on the equation of the parabola and the line, they could not intersect. So that means they won't intersect, there won't be any points of intersection. And another option is if you have a line, let's say you have a line like this, where we only touch the vertex of the parabola, the point at the very bottom, or if the parabola is pointing downward, it'll be the maximum, the point at the top. So it's possible for a parabola and a line to intersect 1 time. These are all the possibilities. A line and a parabola can intersect 0, 1, or 2 times. There's no way for the two to intersect more than 2 times. What about a parabola intersecting a parabola? Well, let's see. What are the possibilities? Here's a parabola. And let's give another one. Here's another parabola. This one's pointing up, this one's pointing down. It's possible for 2 parabolas not to intersect at all. I could shift this parabola up where the two vertices, like this bottom point, they could touch like this. So it's possible for them to intersect one time. I could also move the parabola like this. Here they intersect 2 times. In fact, if I move this parabola up more, the maximum number of times it will intersect is 2. What about if both parabolas were going in the same direction? Like something like this. Well, you can see that they intersect right here. And if we go further up, let me do the green with this one. Green with this one. It's a possibility that they're going to eventually intersect again if you zoom out enough. But the idea here is the maximum number of times a parabola can intersect another parabola is 2 times. So you have 0, 1, or 2 options. Let's find some points of intersection. Here I give you 2 functions, 3x squared minus 7 and 10x plus 1. First I want to figure out what are these the equations of, and then I want to figure out how many times they intersect. And we actually don't have to graph this to find the number of times they intersect. So what do? First off, this is a quadratic, which means it's a parabola. So it's a U-shaped graph because we have an x squared term. This one is a line. Why is it a line? Because we don't have an x squared term. The highest power we have is just this x. You can see that this is at the slope and this is the y-intercept. So now that we know what these are, what the functions are, how do we find the points of intersection? Well, points of intersection are when, or we can find points of intersection rather. Maybe let me rephrase this. We can find where 2 functions intersect by setting them equal to each other. Okay, so let's set these 2 equal to each other. We have that 3x squared minus 7 is equal to 10x plus 1. And now we solve for x. And how are we going to solve for x? This is going to be very similar to finding the zeros of a function, because we're going to combine like terms and try to get everything involving an x on one side. So we get 3x squared. I'm going to move everything to the left. So minus 10x, and then minus this 1, we get minus 8 is equal to 0. You see what I did? I moved this 10x over here and this 1 over here. So I subtracted 1 and made this a negative 8. So now I've set this equal to 0. So what do I have on the left? I have a function. And I've taken a function that's a quadratic function, I set it equal to 0. So what I need to do to figure out where these 2 functions intersect is I need to find the zeros, or rather the x values that when I plug them in, it makes it 0. And to do that, I can use the quadratic formula, which is x is equal to negative b plus minus square root b squared minus 4ac, all divided by 2a, where here the a is 3, this number here, the b is negative 10, and the c is negative 8. I'm going to plug each one of those into this quadratic formula. So the opposite of b, so that's 10 plus or minus square root b squared minus 4 times a, which is 3, times c, which is negative a. And now we have some negatives that we're going to have to deal with, all divided by 2 times a. Okay, let's clean this up. Put some space here. Okay. We get x is equal to 10 plus minus square root 100. I'm going to pull out a calculator. We need to multiply 4, 3, and 8. So 4 times 3 is 12. If we multiply it by 8, we get 96. And then we have a negative times a negative, that becomes a positive. All divided by 6. Let's simplify it a little bit further. This is x is equal to 10 plus minus the square root 196 over 6. Now, I don't know if this is a perfect square or not, but I can figure it out. So what I'm going to do, I want to simplify this. I need to find the factors of 196. Well, let's see. 196 divided by 2 is 98. Okay, so this is 2 times 98. And 98 is 2 times something. So let's see, divide that by 2. It's 49. Look, I have a 4 and a 49. We can double check that. 4 times 49 is 196. So the square root of 196 is the square root of 4 times the square root of 49, which is 2 times 7, which is 14. 196 is a perfect square. 14 times 14 will give me 196. Let's see, 14 times 14. That's right. So then we have x is equal to 10 plus or minus 14 over 6. What do we do now? Well, let's simplify this because we've gotten rid of the square root. We get that x is equal to 10 plus 14 over 6, and x is equal to 10 minus 14 over 6, which tells me that x is 24 over 6, which is 4, and x is equal to negative 4 over 6, which is negative 2 over 3. I found the x values. Now the question, so remember x is 4, x is negative 2/3. Maybe write that down. Let's remember what the question was. The question was to find all the points of intersection. Actually, that's not a question, that's like a, I guess that's a command, right? We found that x was 4 and x is negative 2/3, right? I already forgot, so just let me look back at this. 4 and negative 2/3. Okay. What do we do with this? We found the zeros of that function we set equal to 0. How we find the points of intersection, because remember that we're going to have a line and a parabola. And we're given, these are the x values of where they intersect. To find the point, we have an x and a y value. And all we have to do is we have to plug these points into one of the functions. It doesn't matter which function you plug it into because you're going to get the same answer because they intersect at that point. So I think the easier one to plug it into is this line. So if I plug in 4 into g, I get 10 times 4 plus 1, which is 41. And if I plug negative 2/3 into g, I get 10 times negative 2/3 plus 1, which is negative 20 over 3 plus 1. This is 3 over 3, so negative 17 over 3. So my points of intersection are going to be 4, 41, which I got from this one, and negative 2/3, negative 17 over 3. And I got that from here, because those will be the y values. You could also plug it into this function if you want, and you should get the same answer. Okay, let's try one more, and that'll be it for this video. So we have f of x is equal to x squared minus 4x plus 3. Actually, I don't think this is a line, so this is going to be very similar to what we did before. Let me go down a little bit further. This is the one that I want to work on. Here I have two parabolas. F of x is equal to x squared plus 5x minus 3, and g of x is 2x squared plus 7x minus 27. This is a parabola, and this is a parabola. Let's find all the points of intersection. So I'm going to do exactly what I did before, which is I set the equations equal to each other. So x squared plus 5x minus 3 is 2x squared plus 7x minus 27. And then I'm going to move everything to one side. It doesn't matter which side you move it to. I'm going to move the stuff to this side. So I'm going to subtract x squared. So I get 2x squared minus x squared, which is just x squared. Subtract 5x, so I get 2x. And then add 3, which I think is negative 24. So that's equal to 0. And we can try to factor this. This looks like it could be easy to factor, so let's give it a shot. Two numbers that multiply to give me negative 24, add to give me 2. Okay, 24 is 12 and 2, which is 6, 2, and 2. I think 6 and 4 will work. So 6 times negative 4 is negative 24. 6 plus negative 4 is 2. So we could use the quadratic formula for this. You could try it. It'll take you a minute to do, as you saw with the other problems. But I noticed that these numbers were really easy to work with. I mean, this is a little big, but it was easy to factor. So 0 is equal to x plus 6, x minus 4, because the coefficient in front of here is 1. So I just take this number and this number, put it like that. And now I can get my x values. X is negative 6 and x is 4. Now to find the points of intersection, I just plug these two x values into one of the functions. Doesn't matter which one, you're going to get the same answer. I'm going to go with the first one just because it looks a little easier to work with. So f of x, I'm just going to write it down here, is x squared plus 5x minus 3. And now we're going to plug in negative 6, and we'll get 36 minus 30 minus 3. Ooh, this is nice, if we just get 3. And if we plug in 4, we get 16, plugging it into here, plus 5 times 4, which is 20, minus 3, which is, sorry about that, 36 minus 3, which is 33. So our 2 points of intersection are negative 6, 3, because when I plugged in negative 6, I got 3. So that's the x and that's the y value. And the other point is 4, 33. So those are our points of intersection.